Okay, my little forensic students, this is part 2. Again, part 2 of your glass lab. So we are in your lab book on page 18. I'm going to go over this in a second. You have to make adjustments to your lab book. Like I told you, what they sent with the lab is really not adequate. So before you make these adjustments, let's go back to where we left off so you have an idea of what we're doing today. Okay, we left off on page 17 right here in terms of procedure of step 8. So we're going to do this multiple impacts where we're going to take a piece of glass that's bigger and prepare it the same way as the other one. And then we are going to hit it in a different order. In other words, I choose the order. I could do 1, 2, 3. I could do 1, 2, 3. I could do 1, 3, 1, 2, 3, whatever order, but you have to watch. And then we're going to look to see, can we tell the order? Okay, now, they don't have a place to record your observations. So when we flip over to page 18 and look at this fracture pattern, I have you add a place. Okay, so now at the very top of page 18 in your lab book, I'm going to kind of get closer so you can see it better. We're going to just use a very little bit up here because it's not, you don't have to draw it or anything. You just have to, oh, come on, this is ridiculous with the way this is going today. Okay, that's a little better. You're going to have the question like, how many hits did I do to the glass? Like, how many times did I whack it with a nail in place with a hammer? Then I'm going to pull it out of the plastic, and I will prompt you to say, okay, let's look at the glass. Can you tell by looking at the glass what the order of the hits were and what gives it away? Okay, and I'm going to give you a hint. You really get stuck, look at your notes. You really get stuck, because this you need to know. I'm going to give you pieces, drawings of broken glass and say, what was the order of the impact? So you have to pay attention to this. You just can't do it willy-nilly. This talks about the order of the impact. And then it's talked about over, no, that's refractive index. Over here, it talks about looking at your order of impact. Okay, so just realize that. And guys, don't worry about filling this in on the end. That's why I hate this lab, because this should be in your data part. I don't want you to worry about that. That came from the other lab. As long as you filled in your data table, you're okay. So if you're reading through and you go, oh my gosh, we were supposed to do something there. No, I already took care of that. All right. So you're supposed to do some prediction. I don't have you predict. So let's go back to page 18. You have to make sure you answer these 3 questions. Don't forget about it. This is why I'm taking time right now to say to you, okay, let's fix it. This is the directions. If you are skipping this video, you're screwed. If you know somebody who skipped the video and they're just filling it in willy-nilly, you may want to talk to them, because yes, it's effort, but if you're not paying attention to me, and this takes work for me to do, then I won't give you the points. Okay. I do a double line here so that you realize this is a separate experiment up here. This is density. That's the other part we're going to do in this lab. But because their table is kind of willy-nilly and we don't do water displacement, I don't make a mess by pouring water all over the lab benches, we have to change the heading to one of the columns, and we're going to split the column. So the directions, and I want you to write this down so you can follow along when I do it. What is she doing? Why is she doing that? Because this is the procedure to figure out density. Density goes by the formula mass of something divided by volume. Every single one of you have learned that in physical science in 7th and 8th grade. Every single one of you. You know density is mass divided by volume. So it's not new. So what we're going to do is I'm going to take a collection of a few pieces of glass, otherwise it won't displace the water very much, and it's each particular piece of glass. We don't do windshield glass on this because it doesn't break into pieces we can use. So we're going to use the window or flat glass. Again, this is flat glass. We're going to use the Pyrex, which was the beaker, the tempered glass that shattered into a lot of pieces, and then the big lead crystal glass. So I'm going to put them into a little weigh boat. You're going to see me say, okay, I'm going to weigh the material, watch the balance, record the value on the balance. I will state what the value is on the balance. You need to fill this in. Then this is the column that has to be altered. I'm going to wipe this out. You can just cross it out because we're not doing water displacement. We're actually measuring volume. So I'm going to split this down the middle. This is what we call initial volume at the start, the water that we put into the graduated cylinder, and we take a measurement. This is called the final volume after we add the pieces of glass to the graduated cylinder. Okay, so I'm going to take these pieces of glass that I took a mass for, I'm going to put it in a graduated cylinder, and I'm going to see the difference in the volume. So I'm going to take this value that's final, I'm going to minus initial, and then I'm going to get the volume of the glass. So I have the mass of the glass from the balance. Okay, so this is from the balance. I'm going to have the volume of the glass by doing water displacement. This is called water displacement volume-wise, not weight. They use mass. They fill this beaker really high, and then you drop the pieces in, and the water sloshes over the side, and then you reweigh it. Well, actually, you have to collect the water that sloshes over the side, and you have to measure that. It's too messy. We don't have the right apparatus to do volume displacement by mass. We do it just in a graduated cylinder. So once you do this calculation here, this is the volume of the glass, there's the mass of the glass. We take column A, as I've labeled it, and we divide it by column D, and you will get a value. Okay, so these should go to the hundredths place. You know, you'll have something, dot, something, something, minimally. You might even have to go further than that. Okay? So we're going to do it that way. So I'm going to get ready, and you're going to fill this in. And that's a property, a physical property of the gas. These do not have the same densities. So this is a test that an analyst would do on an unknown piece of glass. Okay, now, once you have this written down, you are going to go to the actual data part, and you're going to watch the video to collect the data for the different pieces of glass and this part up here. Okay, so this is part 2 of your lab.